Good afternoon, everyone. I hope.
Good afternoon, sir.
Yeah, good afternoon.
Good afternoon, sir. Good afternoon, sir. Good afternoon, all.
Good afternoon, madam.
So, respected Principal Dr. Balu, Vice Principal Professor Hemant Uppala, Deputy Director Computer Applications Dr. Kumudavalli, HOD BCA Dr. Aruna Devi, IQAC Coordinator Dr. Gurunath, and my dear faculty members. A very warm welcome to one and all. We are here today, not today, probably the five days, to learn more about computational mathematics for AI and ML modeling, analysis, and research paper writing. It gives me immense pleasure in welcoming our respected principal, Dr. Balu L, whose constant support, guidance, and vision continue to inspire us in all our academic research activities. And FDP is a reflection of our institution's commitment to academic excellence, innovation, and continuous learning. I now request our respected principal to address the gathering. Over to you, sir.
Yes, good afternoon. Am I audible?
Yes,
Yeah,
you're
yes,
audible.
sir.
Good afternoon.
Yes, sir. Yeah.
Good afternoon, sir.
Yeah. A wonderful afternoon to all of you. First of all, I appreciate the Computer Application Department for organizing such a thought-provoking FDP because that is a need of the hour today. Because see, the research and publication has gone one step ahead, right? So we are in the age of ChatGPT, and where AI review is become mandatory. Probably these type of FTPs will equip our faculty members when to write paper, especially in the area of AML. Two things are very much important in this FDP, which I witnessed by looking into the profile of great personality who is conducting this wonderful FTP for all of you. One is the concept of upskilling in the area of research, right? Upskilling is also required in the area of research, which most of us don't do. So probably these 5 days of wonderful FDP will equip all my faculty members to address the future trends, one side, on the other side, to prepare themselves for research paper writing. So in this junction, I appreciate Nirmal Gaur for sincerely accepting our invitation of our department and giving his valuable inputs for next 5 wonderful days. And I also appreciate all my DAC faculty fraternities of Computer Science Department who have made up their mind to attend this type of wonderful FDP. So all the best for all of you. Uh, enjoy enjoy AIML skill sets, and also the output. What we're expecting is very simple. That once you publish paper or when you send a paper for publication, it should come out with a zero AI error. Hope that will be materialized. So once again, I wish the entire team for organizing this wonderful FDP and have a wonderful 5 day journey. Thank you very much.
Thank you, sir. I now request our Vice Principal to address the faculty members about the objective of conducting this FTP. Over to you, sir.
Good afternoon, ma'am. Thank you. Am I audible?
Yes, sir.
Sir.
So, I would like to welcome our principal, Dr. Balu, as well as the resource person, Mr. Nirmal Gaur, to this wonderful 5 day FDP. The FTP was actually conceived way back some time when we saw that many of the computer science faculty members were a little bit struggling in writing good quality papers, especially in the areas of AI and ML. So we thought that rather than focusing on just writing papers, it would be helpful for our faculty members to write a good quality papers, provided they have in-depth knowledge of AI and ML models and modeling, which will definitely help them to understand existing papers, research avenues, so that the outcome would be a more focused research paper. So, more or less, it is like we would like to see ensure that computer applications is no less than a computer engineering. So, we would like to see that level of research papers in these areas. So thank you, both the Deputy Director and HOD Ma'am DCA for facilitating all the faculty members to join this program. And thanks, Lakshmi Madam, for introducing us to this resource person. I have seen few videos of Mr. Nirmal Gaur. His way of teaching is quite impressive. Hopefully, our faculty members would gain much in this 5 days of learning. Thank you and welcome you all for this wonderful FTP. Thank you, madam.
Thank you, sir. It's now time to get to know. Without wasting much time, let me go ahead in introducing him. Our speaker of the day is Dr. Nirmal Gaud, CEO and Master Trainer, Think AI and Cognitive Research. He's a CEO of this particular institution, and his areas of interest are AI, ML, deep learning, generative AI, data science, and Python programming. Nirmal sir has received a doctorate from VIT Bhopal with a ME and a BE degree. He is also worked as assistant professor in different colleges in Bhopal. He's been actively conducting training classes regularly on weekends, and even few classes of his I have attended, which has given me a great insight into my research topic. I request Nirmal sir to take us to the learning journey of this 5 days. Uh, Over to you, sir, Nirmal sir. Thank you.
Thanks a lot, madam. And I would like to thanks Principal Sir, Vice Principal Sir, Director, Coordinator, and all the faculty members, Lakshmi ma'am, to ask and gave me a chance that, sir, we should conduct a workshop. And as per her initiative and the platform given by all the respected principal, vice principal, director, coordinator, and you all faculty members for this part of faculty development program. I would like to thank everyone that this opportunity, as per the objectives decided to enhance the skill of AI, machine learning, deep learning, paper writing, we will definitely, from my side, I will do my best. And I will share as much as of my expertise in this particular field and help us all to grow. So let's get started. Well, artificial intelligence, the topic of our workshop, that's 5 days FDP, is computational mathematics for AI and ML, basics of modeling, analysis, and research writing. That's what we have decided for these 5 days FDP. So we need to talk about artificial intelligence. We need to talk about machine learning. We need to talk about deep learning. We should also discuss about generative AI, data science, paper writing. All these things will be covered in this FDP. Artificial intelligence, okay, AI. We want to make mimic of humans. That means we want to achieve same kind of intelligence in machines, just like that of humans. It means that we are not relying or trusting on humans. Let's what I think we can say. Our most of the work task is been done by machine, and we want now machines to have similar intelligence just like humans. That's what AI is, artificial. Okay, because we are expecting that intelligence in machine, so that will be obviously artificial. All right, so AI is a big domain. In AI we are having machine learning. Well, you want to make a machine intelligent, then you need to do something with the machine. How you can make it intelligent? So, in order to make a machine intelligent, you need to train a machine. Okay. So, in order to train a machine, we require data, because how machine will get a knowledge, how machine will get intelligence, unless and until there is no data, machine will not become intelligent. That is why we require data. Okay. So we feed data into the machine, and we perform a training of this machine with the help of some algorithms, some techniques. These are called as machine learning algorithms. And then we expect a prediction from the machine. Okay. This is what happens. So, data, which we call as raw facts and figures. Okay. Data have many forms. Image can be a data, text can be a data, audio, video, all these are data forms. And you also prepare the records like in Excel file format, tabular format, where you fill the entries. This is also a data. Okay. So we feed such kind of data into the machine, and there is a training. Well, if in a data we are having target, what to achieve? Okay, what to achieve? So data with a target or label is called as supervised learning. Supervised. And data without a label is called as unsupervised learning. Unsupervised. So what exactly I'm trying to tell here? Let us say you are having a data where I'm mentioning experience and salary. Okay. And here are the entries for it. 2 years experience, 10K salary. 4 year experience, 20K salary. 6 years experience, 40K salary. 8 year experience, 60K salary. It means that let's say salary is your target, experience is your input. We all know, like in maths, y equal to f of x. Okay, where x is independent variable and y is dependent variable. We know about it. Here also same thing is there. Experience is x, salary is y. So salary is dependent upon experience. All right. That means you are available with x, you are available with y, both. Now, if a question comes, how much will be the salary for 10-year experienced person? Okay. We do have an equation y equal to wx plus b, a linear equation like y equal to mx plus c. If we consider data this much, we are having x also, we are having y also. Okay. That's what we are having. Our expectation here is we need to predict a salary. Okay. Since salary is target and it is available in our data, such kind of learning will be called as supervised learning. So if in your data target is available, label is there, I'm calling this as label, target or label. It is there in your data, then it is supervised. If target is not there, label is not there, let's say if salary was not present here, then it will be unsupervised learning. Now the question is, okay, you have made it clear that in machine learning we are having in general two types. There are other types also. In general, supervised and unsupervised. Supervised means you are having target available in your data. Unsupervised not available. Okay, and then we need to make a model, a algorithm, a technique which can understand this data, or I would say technically which can understand patterns in the data. This is much more technical, patterns in the data. That means how y is related to x. Now I need to understand this pattern, this relationship. So we do have an equation y equal to wx plus b. Here, salary is 10, years of experience is 2. Salary is 20, years of experience is 4, 40, so on. I have made these equations. You are available with x, you are available with the y. But what actually you don't have? What actually you do in training? And why I will do training? It's quite clear that I am looking forward for W and B. I don't have these terms. These are called as parameters. Okay. And with training, we identify these parameters only because you're already available with y, you're already available with x. You need to find parameters, that is weight and the bias in general, I would say w and b. Okay. And once you get these parameters, next time if you have been asked, kindly tell us what will be the salary for 10-year experienced person. You are available with w, you are available with b, you can just input the experience, you will get the salary. Why? This is what we do in machine learning, in model training. So model is nothing but a statistical, it's a statistical representation. Okay. Machine learning models are statistical representation. These equations, mathematical equation. That is why the theme of this FDP is computational. We should understand maths also, maths background also. That how algorithms are built, how algorithm which are existing working, how results are coming. And then once we have an idea about data and algorithms, we can write some papers. So knowledge is important. Mathematical foundations are important. All right. So in machine learning, that's what it is defined. We give data to the model, statistical representation, and we do training. Training means to identify the parameters, best suitable parameters for that equation. This is called as training. Okay, and after training, once we get these suitable parameters, now you can do the prediction. This is what happens in ML, machine learning. So identifying patterns in the data. All right, got it. Identify patterns in the data. Okay, but like as I said, machine learning is simple mathematical model, statistical representation. And once the data keep on growing, machine learning data pattern finding will be getting challenged. It's getting complicated. Okay. In machine learning, we do have supervised, unsupervised. We are having semi-supervised also. Semi-supervised. We are having reinforcement learning also. In unsupervised, we don't have the target or the label. For example, you are having a data set. You are having a data set. These are the features which are present in the data, and we don't have why here. No target. And the goal in unsupervised is to group or to make cluster of data points which are having similarity. Okay, on the basis of similarity, you make group or the cluster. Similarity is identified by again maths, like to find the distance between data points. Distance between data points. This is how I can identify the similarity between the data points. Okay, so you will be having the distribution of data like this. Let's say this is 2D plane, and this is a cluster or a group. This is a cluster or a group. Okay, the data points distance here is less. This is a centroid. Here is a centroid. We do have the algorithms. We do have the algorithms which find the distance between the data points, and if it is less, then we will merge them, put them in a same group or a cluster. So this is cluster A, this is cluster B. Okay, we don't have the label, but actually we identify the distance between the data points and then convert them into a label. So this is, let's say, such data points following label A or group A. These are following label B or group B. So distance based. All right, that is unsupervised. In semi-supervised, we do have some part of the data which is having label, some part of the data which don't have any label. Okay, so it's a mixed kind of learning. In reinforcement learning is a different strategy from supervised, unsupervised, and semi-supervised. Let me share my entire screen and explain you more about it. In reinforcement learning, the best example is, I hope you have heard about a driverless car. And what happens in driverless car? You are having the agents, like let's say cameras, which are continuously monitoring the activity or the actions. Okay, so like in a driverless car, what happens? It need to take an action. If there is an obstacle come, then like either need to stop or either need to take left turn or right turn or whatever. It need to take a decision. So in reinforcement learning, what happens is the system learns based on actions. Okay. So we do have agents in a system which are continuously monitoring the situation and they are taking actions based upon the rule. If the action is taken correct, then we are going to give a reward. And if the action is incorrect, then there will be penalty. Okay. If the wrong decision, wrong step is taken, then you will be penalized. And if the correct decision, correct step is taken, then you will be given a reward. So reinforcement learning has been there. And right now, obviously, the machine learning models, they do have reinforcement learning present in it. Let's say, as sir also told that we are in a chat GPT era, and since you give any kind of prompt and you are getting all kind of answers, so what is left with us? What is left with us? If we don't explore, okay, for the 5 days, like the discussion is related to exploration. We need to explore. We need to open up our mind. Because what is research? Research. Okay, there is a like break it. Research. Someone has searched for a particular problem statement, gave some solution. We are researching it again on this problem statement. We are not satisfied with the solution given by that person. So we want to develop our own technique, our own solution for it. That will be a better solution given by the person, previous person. Okay, fine. So, for this particular thing, we should have a title in our mind. What is our title? What is our problem statement? Right now, there are so many problem statements are there. So many. If we talk about the applications of AI, artificial intelligence, it is applicable to medical imaging, healthcare. It is applicable to banking and finance. Okay, there also scope is there. AI in education, AI in governance, AI in sports, AI in entertainment. Okay, everywhere AI is applicable. Okay, you need to select your area of interest. And if you are good in AI foundations, then obviously you can achieve your goal by developing some algorithms, some technique which are better than the previous one. And and obviously, as I am explaining about the mathematical thing, I will be talking about all the topics. Just give me some time. All these applications. Okay. So in research, the important thing is about ML. Just right now I explained its categories: supervised, unsupervised, semi-supervised, reinforcement learning. Let's say supervised learning. The algorithms which are used in supervised learning is divided into two categories further. One is regression, another is classification. Regression and classification. In a regression, we are having target which is continuous in nature. I will be explaining the entire data distribution also in front of you. And you need to make a note of it. Very important. So if your target is continuous in nature, like price, okay, price it's continuous in nature. Then it comes under a category of regression. And if it is categorical in nature, then it will comes under classification. That means if your target is 0, 1 or A, B, C, like this, then it comes under classification. So regression and classification. In classification, we do have binary classification, we do have multi classification also. If there are two categories, 0, 1, then it is binary classification. If there are three categories, three or more, then it will be multi classification. Okay, like as I said, A, B, C, there could be more classes also to classify. Then it's multi-classification problem. Okay, got it. This is supervised. And the algorithms used here are, if you heard the names, linear regression, logistic regression, support vector machine, decision tree, random forest, XGBoost, such algorithms are there. Naive Bayes. Okay, these are the algorithms which we can apply for regression and classification. Okay, in unsupervised, as I told, that you don't have the data or the label present with you. So the algorithms there will be to identify the group, to find the clusters. Okay, like K means algorithm, K medioids algorithm. Okay, that means clustering algorithm, DB scan, density based spatial and clustering, DB scan algorithm. There are so many algorithms which only the goal is to identify that how data points are closer to each other. That's what they do to make a group of these data points. This happens in unsupervised. Okay. All right. So the overall idea is to find data patterns, and these data patterns are defined by some equations. Some equations. These equations are represented like mathematical or statistical representation. Got it? Fine. Now, well, if you want to approach to a particular problem, we don't jump directly, and don't do this thing. We never jump directly. If you want to write a research paper, obviously you need to first do the implementation. You need to write a code for it. Then you need to generate the results for it. You need to use some algorithm, some technique, and results should be generated. And if the results are good, then only you can write something. Well, it's not like we directly start the code. No, 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 not at all. Data. This is what you need to understand. Mandatory. Let's say you are having a problem statement for multi disease detection, and you are available with the data, such and such kind of record available with you, and you need to use your machine learning and all this to detect the disease. Well, the first step is data understanding, very much important. When you see a data, a record, like this way, the one which I made, there are two kind of entries present in it: numerical, non-numerical. Okay, numerical and non-numerical. Numerical can be further divided into discrete and continuous. Discrete means countable. Numbers which are countable, they are called as discrete. And the numbers which we cannot count, we represent them in some interval. They are called as continuous. That's what I said. In supervised machine learning, if you are dealing with regression problem, then the target is continuous in nature. That means we need to represent them in some interval, in some class interval. Then it is continuous in nature. For example, if the data distribution is like this, 1.5 2.7, 3.8, 4.9. Okay, you will be making a interval 0 to 5. This will be the interval, and you will be marking the values. How can you count 1.5? No, interval. Discrete are countable. Okay, I am having 5 fingers. Discrete. Okay. Or the numbers like 0, 1, discrete. This is continuous. In non numerical, we are having categorical and non categorical data. Categorical and non categorical data. Okay. It's clear that if you are having class or category, then it's categorical, else no, it's non categorical. In categorical, we are having furthermore category, furthermore division, that is nominal and ordinal. If we are having a category and there is an order, for example, like in institute also, principal, vice principal, director, there is a rank. Okay. Assistant professor, associate professor, professor, there is a rank, there is an order. So if we are having a category, it is represented by an order, then such kind of data is called as ordinal data. And if we are having a category but there is no order, then it is called as nominal data. For example, let's say three colors: red, green, and blue. Either of them can come in either position, not an issue. RGB. There is no category for it in terms of order. It's it can be put anywhere. Okay, so such a categorical data where order is not important, then it's nominal in nature, else ordinal in nature. Okay, got it. This is the data distribution. So whenever you are receiving the data, you need to mark. You need to mark. Okay, these are discrete features. These are continuous features. These are categorical features, ordinal, nominal, and these are non-categorical features. This is what you need to mark. So data understanding is important first. Okay, got it. Then only you can plan something to do, any activity over the data. Okay, got it. Obviously, you should be knowing your problem statement. What I need to do. What? What is my aim? What are my objectives to achieve? These are the objectives. Okay. This is the step number one. This is the first objective, then second objective, then third objective, then fourth objective. After my all objectives will be done, my aim will be completed. That's what I need to do. Okay, so what's the problem statement? What's the problem statement? You need to identify the problem. And how you are going to identify the problem? Okay, you have picked some research paper as per your topic of interest. Let's say you are working in healthcare domain. You picked any topic. Let's say, let's say brain tumor detection. Okay, brain tumor detection. So you will be downloading the latest research paper, maybe open source repository. Okay, I mostly check out from archive, arxiv. Okay, this is open source. You can find the papers, you can download the papers. All right. And if you are available with scopus, sci, ieee, okay, that's a good idea. All right, from reputed journals with good impact factor, you download the paper, latest one, let's say 25, 26, as per your topic of interest, brain tumor. Okay, You download the paper, you read the paper. Okay, you read the paper. What's mentioned in the paper? Okay, title. Title will let you know that what kind of algorithm or what kind of technique these person have included in the work. And obviously they will be targeting some architecture. Now let me clarify you more things. Where actually the researchers? Where actually the researchers? Research. According to me, two possibilities. One is either you are building your own algorithm, your own architecture, your own technique. Okay, so one scope is architecture. Architecture. Sir, we are building our own framework. This is my architecture. Sir, we have been told that make a hybrid architecture for detection of this. Okay, okay. Or either there is one more scope, neural network. Okay, neural network. This is also area of research. Now, let me speak about deep learning, and then we'll connect here in the research part. Deep learning. Well, what happened? Machine learning, as I said, that if the data is less, so you can apply machine learning techniques and you are going to get the good results. But data is not in our hand, data is continuously growing. Data is continuously, every second data has been added, accumulated, okay, and so much bytes of data has been there. So using machine learning algorithm which are based upon simple mathematical statistical technique, no, they are not going to identify the patterns in the data. No, that's not the deal. Okay. So we needed to think more. We need to apply some better algorithm, and that came by deep learning. Deep, okay, think deep. In deep learning, we are having neural network. You know about it. Neurons. Like biological neuron, we are having artificial neuron. Sir, what we do is we create here layers. These are called as artificial layer. In layer, we do have the neurons present. There will be, sir, neural training, sir. We give the input, and this input is transferred forward by the neurons, and here we are getting the output. This is the input. So there is a neural training, sir. Okay. And neuron, which I am calling as an artificial neuron, this one, you give input, you take the output. Neuron is also having the parameter w and the b. Again, let me write the equation y equal to wx plus b. This is the equation. And you will be surprised, with this equation, we got the Nobel Prize in physics. Sir, this equation is a linear equation, sir. Y equal to mx plus c. We are getting Nobel Prize on this equation. Yes, we got the Nobel Prize in physics on this equation, wx plus b, for neural network. The idea was, okay, in our brain we have organized, we are having biological neurons all connected to each other. Let's make an artificial neuron, and every neuron is going to do this thing, wx plus b, weight and the bias parameter. Okay, got it. So, we give the input. We give the input. Let me make a very small neural network. Like, let's say this is artificial neural network. This is the input. This is intermediate layer. This is the output layer. So this is input layer. This is hidden layer or the intermediate layer, and this is the output layer. We give input. Okay, inputs. Let's say x1 and x2. These two are the inputs. Okay, x1 and x2, these two are the inputs. Every input is given to every neuron. Remember, remember, x1 is given to this neuron also, this neuron also, this neuron also. X2 is given to this also, to this also, to this also. All right, got it. So at every neuron, if I consider this neuron, the output y is given as summation of wi xi plus b. Okay, xi, let's say x1, wi, let's say w1, x2, w2. So every input will be multiplied by weight. What is the weight? Sir, you are calling as a weight. What is weight? No, I'm not talking about kilogram. I'm not talking about a gram. No, I'm not talking about. I am talking about weight. Weight is a strength of interconnection. Strength of interconnection between two neurons. Strength of interconnection between two neurons. This is called as weight. Okay. If the weight is more, the transfer of, okay, you know what I did? It's clear. I am writing y equal to wx plus b. Okay, fine. If the input is 10, weight is 0.1. How much will transfer? 1. If the weight is 10, input is 10, how much we are going to transfer? 100. That is why weight is a strength of interconnection between the two neurons. Bias is an error term. Okay. We need to complete the equation. Na? Y equal to mx plus c. So y to left this part, this one bias term. So let's add bias also. Okay. Bias. You know, it's bias is something used in electronics like error something. Okay. So I'm just incorporating bias also here. Just to complete the equation. So it will be y equal to wx plus b. So these two are the parameters, learnable parameter. All right. Therefore, you are giving X as an input to the neuron, you are getting Y as an output from the neuron, subject to weight and the bias, you are getting Y equal to WX plus B. Before giving this Y to the next neuron, we need to pass it through activation function, AF, activation function. Well, as I said, in machine learning, deep learning, we need to identify patterns in the data, and patterns will be more likely to be non-linear. In real life, things are not straight. Okay, not straight. We are not expecting smoothness. Data is not like that to smooth. Okay, got it. So, non-linear. You have to consider this thing. Non-linear relationship, especially. So once you get a y from this, you need to pass it to activation function. An activation function is a function which is non-linear in nature. Okay, it's non-linear in nature. Like some of the activation functions are, let's say, a ReLU, rectified linear unit. It looks like this. This is ReLU. That means if any input is negative, output is 0. Okay, so anything from here, the output will be 0. But if any input is x, output is x only, positive. If any input is positive, then answer is same only. This is ReLU. We are having so many other functions, activation, sigmoid, tanh, leaky ReLU, swish. There are so many activation functions. Hundreds of activation functions are there, non-linear in nature, to identify non-linearity in the data, relationship in the data. All right. So how the thing goes? How the thing goes? Uh, Input given to the neuron, output y, pass through activation function, then whatever be the result you are getting, now pass it to the another layer neuron. This is what happens. This is what happens. Okay, got it. Activation function, sometimes also called as fire up, to fire up the neuron. Because what happens in our brain? What happens in our brain? The energy get accumulated in the neurons, and once the threshold is achieved, then there is a spark. Then that will be transferred. That energy is transferred. That signal is transferred to the next neurons. This is what happens. That's what the task of activation function is. All right, got it. So, like, how to make a neural network? How many neurons are there required? How many layers are required? Okay, does every neuron important while training, or we can reduce the neurons? That is also area of research. But mostly we people are strict towards, okay sir, once we are making a model, once we are making a model, so sir, one part is the architecture part. In architecture we make our own layer, custom layer from our side, and then we are having a neural network, neurons present here. So that we keeps are not that much in important. We make a neuron so that neuron will train. That is not an issue. Our more concern is here. That is why you have seen many of the research paper, a novel architecture, hybrid architecture of this detection, that detection. These people like working on the architecture part. They are making them their own layers. All right. So what do you want to do by these layers? What exactly we are doing? We are available with the data. We pass it to the architecture layers. This architecture. Okay. From here we extract relevant or important details present in the data. Details present in data. Present in data, and then we give it to the neural network for training. We don't give directly data to the neural network for training. We build some architecture from our side that will extract the relevant details from the data, and these layers which we call as architectural developments. Okay, architectural developments. Moreover moreover like research will be focusing upon, first you have made your own architecture, your model, your technique. Okay. Second uh, second computational capability, computational resources. Whatever you made, how much computational resources it is taking. That means how much memory, how much execution processing. Computational means processing and memory. So your research will only be successful if whatever you have made as an architecture, as an algorithm, as a technique, as a model, if it requires less processing time, less memory, and give high accuracy or high scores, then you will be successful. Because you need to mention in your results, in your research paper, you need to mention in your result that here is the table, here is the table, comparative table. Okay, comparative table, you are going to write algorithm, you need to write the scores. This is the algorithm, basic machine learning algorithm. This is the algorithm, deep learning algorithm. This is the algorithm given by an author, previous research author. Okay, and this is the algorithm which you have made. Okay, this is yours. Okay, and here you need to mention your score. Let's say the previous author score is 98 and you have made 98.2. You are in a winning situation. You are a winner here. 98.2. All right, got it. So, like, you need to apply basic machine learning, you need to apply deep learning, you need to apply author mentioned algorithm on the data. Okay, and then you need to apply your own technique over the data. Got it. This is what you need to do. Then only you will be like in a position to submit your paper. Okay, fine. Got it. Okay, fine. So like here, once you get a paper as per your topic, as per your interest. Okay, got it. You read it. Okay, you understand the title, what is mentioned in the abstract. Okay, in abstract now listen carefully. Listen carefully. Abstract. You know how the abstract starts? How the abstract starts? Abstract starts by by telling a short introduction. Okay, let's say brain tumor. Brain tumor is this kind of disease, and from the second line itself, they tell negativity of the work done so far. Remember this thing whenever you write an abstract. Okay, because you are working on a particular topic, you are working on a particular subject, so you first like write an introductory line. Brain tumor nowadays is a very serious problem, it's a concerning problem. Okay, and like because of the lifestyle and of other limitations, people are suffering from it. Then you directly hit to the limitations from second line itself. Target. So far so far the work done by the previous authors or the techniques used by them are limited because of so and so. There are challenges which are not considered, and due to which there are lacks, and still we have many things to achieve. So first line introduction, second line is limitation of the previous work. That is why, that's the only reason your paper, at least we don't have to bluff. Okay, but someone, why someone read your paper, someone read your abstract. First a title. Okay, title is looking, they have made some algorithm. Okay, let's go into it. What kind of algorithm? Let's go into it. So they will read the abstract. In the abstract, the first line should be what you know about your topic. That is why I mentioned a simple introduction part, that this is the tumors. And then you should directly do the, you know, bad or the drawbacks of the previous work. All right. This much you need to write in. Okay, if your abstract is having 150 words, nearly 150 to 200, okay, at least four lines should be covered by this. All right. Four lines should be covered by this. So kindly make a person understand that why you have done this research. You know about the topic, you know about what is the limitations of the past work. That inspired you that we should also do something here. After doing all these things, then you write, due to this, we propose a novel algorithm, or we propose a technique, machine learning based, deep learning based technique. Name of the technique, kindly put a name of that technique. What technique you are proposing? We propose this technique in which we have introduced so and so layer, or so and so maths, whatever, like the things which you have done in order to achieve the good feature extraction. That's what you need to write. All right. So your proposal should be mentioned here. Your architecture name, it's hybrid in nature or whatever. If any layer you have built, any mathematical algorithm, any technique you have built, you have to mention here. So just 2 to 3 lines, like I am expecting, you should write here in the abstract. Got it. And after writing 2 to 3 lines on this, then in our experimental results, in our experimentation, okay, in our experimentation, we achieved how much scores, you need to mention here. In our experimentation, we achieved these scores. Okay, let's say 98.2% of accuracy. In our experimentation, we achieved these scores. Okay. Over over less computational complexity, less resources. Okay, less resources, less so we need to now make ourselves positive, turn the game, turn the table, turn the table. Now it's on your side in comparison to others, in comparison to others. So you have turned the table now on your side. This is how you need to write an abstract. All right. Okay, if you want to take a help from AI assistant, that's okay, but take it, but write in your words, like, all right. But the approach I'm telling, the approach I'm defining, it should be in this way. I read so many papers, as madam also told that she has attended my workshops, and I read the papers in my workshop, what the authors did, and the papers are organized in this way only. They gave a title, attractive heading, and in the abstract they start with introducing their topic, like core topic, brain tumor. They introduce this thing, then the limitations of the previous one, then their proposal, their achievement, their benefits. This is how they end their abstract. So you have to, like, complete all this game in 150 to 200 words max. Mention your keywords. So once you are done with the abstract, mention your keywords. Got it. Fine. Let's say 5 keywords. 5 keywords are okay, which you are going to introduce in your paper, rest of the paper. All right. So title, abstract. Got it. Fine. Which areas research is going on? See, applications of AI, I already told you. Already told. Fine. There are so many applications of AI, and if you are dealing with the Healthcare part, I told about brain tumor as one of the case. So look out for the generals. Look for generals. Okay, there are many generals are available, and according to their like Scopus or SCI indexed generals are there. Okay, kindly check in MJL Claravet. Okay, about the details. From here, you will get the detail. You put the general name here. You'll be available with ISSN number, all e-prints and all. Okay, from MJL Claravet, now you'll get an idea that what is the indexing of the general. All right, from here only you will get it. Fine. And like I have seen, like high impact factor and generals, maybe some generals which don't take any charges, they take a long time for review. Okay, some paid generals, they take less time. Now it depends, like are you getting financial support from the institution in publications or what, we'll see ahead. Okay, so this is how you need to make a title and the abstract. Okay, got it. Your title should also be according to which will catch the eye. Okay, these words: hybrid, novel, a name of a new layer, mention, algorithm, technique. Okay, people like say, sir, in research, na, we need to make our own architecture, so we'll keep some name to it. Okay, keep the name, keep a name for it, not an issue. That should be present here. Okay, fine. Now, deep learning I explained, paper title, abstract also I explained. Then comes generative AI, Gen AI. Okay, let me talk about this Gen AI also. Well, from machine learning to the deep learning, as I said, in deep learning, we do have a lot of data. Now it came into the mind that if you are available with lot of data, can you make an algorithm which can generate data also? Okay, which can generate data also. If you are available with a lot of data, is there any architecture which can generate data? Yes, yes, yes. That's what you are using. Chat GPT. That's actually GPT called as generative pre-trained transformer. That is generative pre-trained transformer. Transformer is an architecture. Okay. Transformer is an architecture. And this architecture just made it successful for text generation. Text generation. So we consider this thing in generative AI, something which is generated by artificial or a machine. We call it as generative AI. Okay, so either it's text generation, either it is image generation, any kind of generation, either like from text to image, image to text. There are so many things are happening right now. So many things are happening. Okay, got it. So the architectures which are used here, as I said, transformer, that is one of the successful architecture. And you can read 2017 paper if you know. I guess you have came across such a 2017 very successful paper. Attention is all you need. Attention is all you need. This is the title of the paper. 2017. Kindly read this paper. This is the benchmark paper. Because of this only, this chat GPT and all these things, all these AI tools came. Attention is all you need. Not so much big paper. Okay, but you read this paper and try to understand what is this attention mechanism. Why what they are saying. Okay, and the logic which is used now, the logic which is used is encoder and decoder, encoder and decoder. This is the logic used in generative AI. In encoder, we call it as compression. Decoder, we call as decompression. Okay, compression and decompression. In compression, in compression, you know what we do? We reduce the size of neural network. We are having a data, give us an input to a neural network, remember, neural network, starting from let's say 1024 neurons, then 510 neurons, then 256 neuron, then 128 neuron, then 64 neuron. So we compress the data in encoder, this part, compression. In decoder part, we decompress or revert the process. Reverted. After 64, 128, 256, 512, 1024. And from here, we take the generations. So such kind of architectures has been built. Autoencoder, transformer. Okay. This phenomena only has been used in text, image, audio, video generations. Right now, we are in a very advanced positions. Like we are dealing with multimodal data. Multimodal. We take image also, text also. Nah, right now, you are using these AI tools, and you just write kindly create this image. So model is creating the image. So text to image generation. The model is trained with text also, image also. Together combined. That is the reason right now you are giving a prompt and you are getting the images from it. Okay. So advanced architectures are there. And there's what the research is. Okay, you know about people are talking about AI agents. Okay, LLMs, large language models, large language model. What is a language model? Model, okay, you know, it's a machine learning model. Language model, okay, something which can understand the language. That is natural language, the one we speak. So if the machine is going to understand your language and reply in your language, that's a language model. Large means okay, a model which is trained on large amount of data, huge amount of text, huge amount of text. That is called as a large language model. Okay, noted. So LLMs are there. Chat GPT is a language model. There are so many models. Okay, Gemini, Meta, Meta Llama model of Meta. Okay, Grok is a model of Elon Musk, this Twitter. Okay, and GPT, OpenAI model. So many models are there. Language models, large language models. All right, got it. Which are further turned into AI agent to automate the task. Automation. Right now we are having AI agent. Industries are working on AI agent. Like you use LLM as a brain. LLM is used as a brain. You give a task. Okay, you give a task prompt. We are having already LLM. LLM is associated with various tools or the apps or applications. Like let's say Gmail. You give a command to the LLM. Kindly write an email for me to this that today there will be a meeting. So LLM will frame the entire message and it will forward also. So now we are having task automation. That's the reason that every time there is a question game that jobs are affected by AI. AI is a skill, according to me. Job affected if you are not learning. If you're not doing exploration, if you're not doing research, obviously you will be replaced. In every era there is a replacement. Okay, so you need to learn a skill to keep yourself safe. You need to keep on researching, then you will be safe. You need to keep on exploring, you will be safe. Else you will be replaced. That's it. Got it. Like AI agent, we have came, and further research is going on. Let's see, more products will be delivered. Got it. Now, in order to make ourselves strong, and the title also says for our FDP, like computational mathematics for AI in machine learning, we should be good in computational part, we should be good in mathematical part, then only we can make it successful. All right. So, sir, what topics will be there to make ourselves strong in AIML? Linear algebra, very important. Let me clear you the topics. Linear algebra. In linear algebra, what you have? Algebra deals with equations. Okay, it deals with equations. So, in linear algebra, you deal with the equation y x. We require some simple mechanism to solve these equations. And the simple mechanism to solve the equation are matrix, okay, vectors. You should be good in vectors, you should be good in matrices, what operations they perform. You should be good in it. Good in it. Okay. Two, it's a scalar quantity. You know about it. Only magnitude, no direction. Scalar quantity. 2 I cap, vector quantity. Magnitude with the direction. So scalar, vector. 2I plus 3j, or let's say I am writing it in this way. If we increase the dimension matrix, so scalar quantity, vector quantity, matrix. Now, matrix within a matrix. This is called as tensor. Tensor, high dimensional data. Tensor. Okay. So we do have tensors only. We do have tensors, high dimensional data. Okay. Now what I am saying, you remember this thing, tensors. Okay, high dimensional representation of data. If I say you are available with a data sheet, this is your data sheet. All right. Columns or the features are x1, x2, x3, x4, x5, y. Here, if you want to represent it, if you want to represent it, x1, okay, this is y, this is x2, this is x3, this is x4, this is x5. Every feature is represented by a axis or a dimension, and all are perpendicular to each other. All these are perpendicular to each other. Okay, got it. Perpendicular. This is the easiest way. We have learned now in our schools also coordinate system, Cartesian coordinate x comma y. So this is the easy way to represent. So if I am having a entry present here, let's say the entry is 2, 3.5, 4, 7.1, A, answer is 100. So I will be writing it like in this way. Any of the point represented by a vector, it is having 2 comma 3.5 comma 4 comma 7.1 comma a 100. This point is represented by all these values. So whenever you see a record, whenever you see, it can be represented in data points in this way. It's the easiest way. Okay, got it. Now, by this representation only, we can make it as a vector. Okay, sir, this is a vector. Make it as a vector now. Make it as a vector. Okay, vector 2, 3.5, 4, 7.1. Okay, ignore a right now. This is x input, and this is y output. So we are having other rows also present here. We can make a vector, and in combine, it could be like a matrix. 2, 3.5, 4, 7.1, then 1, 2.0, etc., 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 like this. This is a matrix. So if you are available with the data, you need to represent data. The best way is using vectors in the matrices. And this is the output y. 100, 101, 99, 98, 97, whatsoever. That is why in data science and in machine learning, matrices and vectors are important because you can add them, you can subtract them, you can multiply them, you can find inverse of a matrix, you can find adjoint of a matrix, you can transpose a matrix. So many things you can do over a matrix. That's the reason if we are available with a record, a table, we can organize it, we can represent it in this way, and we can apply mathematical operations on it. And that is with the help of which your machine learning model is made up of. Your model is made up of, I told na, statistical. Okay, I'll talk about statistics also. Okay, this is a linear algebra. So once you do this thing, you can apply required steps on the data. Got it? Fine. Okay, I do have the notes for it. I'll share it to you, everyone. Okay, you can read the notes for linear algebra, everything. Okay, but today I'm just describing what are the requirements. So algebra, matrix and the vectors, very important. Okay. Then comes after algebra, statistics. Statistics, very important topic in maths. Second, after linear algebra, statistics. It talks about distribution of data. Distribution of data. Previously it happens to be like the people do the degree in BSc or MSc statistics or something. Okay, but most of the things were captured by computer science. So, if you are a CSE person, then you are going to get a job because we are having IT companies more. Okay, IT companies are going to get a job. You are a CSE person. Other branches, people also like they learn programming and they sit into campus selections for the companies which visit, especially IT background companies. But when this AI came, data science get more weightage, and with this skills, people started getting job in this particular field. At my time, also the same thing. I guess at your end also, a computer science. But this is good initiative that right now colleges are having the branches related to AI, ML, data science. But the things what we are struggling is the experts, and what it requires for the expertise is this FDP is telling mathematical foundation, computational analytics part. This is what this FDP is telling. What it requires for to be a good AI ML engineer, maths. Okay. So statistics distribution of data. Okay. Whose distribution I'm talking about? Discrete, continuous, categorical, non-categorical. Got that. This is how we represent data. Whose distribution I'm talking about? Okay. If we are having discrete like 0 and 1, for distribution I can make like this. Okay, for 0, 100 entries are there. For 1, 20 entries are there. This is how I can show the distribution. I can make a pie plot. I can make a pie chart for it. I can make a counter plot for it. This is counter plot. This is pie plot. And you need to put these into your research paper. Okay, we got a data and this is the distribution of our data. So we are explaining our data set while preparing methodology. There is one point in your research paper that is data description. So you need to describe your data. We have taken this data set from this sources. In this data set, this much entries are present. In this much number of entries, the distribution is as follows, and you need to include image in your research paper based upon the distribution of data. Okay, so one point is important in methodology: data description. Okay, statistics distribution of data. Well, we are having two types of statistics: descriptive, descriptive and inferential. Descriptive statistics and inferential statistics. Descriptive statistics stores about, obviously the distribution is like count of entries, which is the maximum entry, which is the minimum entry, what is the variance, what is the standard deviation, and percentile also. Percentile. These things are present in description. I need to describe my data. So for statistical description, we require all these things. Okay, all these things: minimum, maximum, variance, variance. How far a data point is from its mean, that is called as variance. Okay, how far this is mean, let's say x bar, how far this point is away from its mean, this is called as variance. And standard deviation, square root of variance. Okay, got it. Represented by sigma, standard deviation sigma. So mean is represented by x bar and also by nu. X bar means sample mean. Nu means population mean. Where we are considering the entire data points, that is population. And X bar is sample. Okay. From a population, you have taken a sample. Its mean is X bar. Nu is the entire population. Entire mean. is new. This is standard deviation. Both are like technically okay, fine. So these things we talk in descriptive statistics. In inferential statistics, we do have hypothesis testing. Hypothesis testing. We need to prove something. Hypothesis. Hypothesis is a statement. We need to prove this statement, whether it's right or wrong. Okay. And we consider this hypothesis based upon sample of the data. Based upon sample of data. Okay. Like if we consider a statement or hypothesis that that this party is going to win elections. This party is going to win elections. So there is a survey done in a city. In city, we are not going to ask each and every person. No. In a city of 10 lakh, okay, in a city of 10 lakh, we are going to ask only 1,000 people. We are going to ask only 1,000 people as a sample. And based upon what these people said, we will claim that party X is going to win the election based upon these 1,000 people sample only. And it will be applicable for the entire 10 lakh people. It is applicable to all. That is the hypothesis which we want to prove. Okay, so we do a survey analysis on small sample of data, and we apply it to the entire population. This is what happens in statistics, especially in this inferential statistics, hypothesis testing. There are so many techniques are available. There are so many techniques are available depending upon the data. Like, are you considering numerical data? Are you considering categorical data, non-numerical data? So we are having like ANOVA, analysis of variance. Okay, size square test. There are so many tests are there, and you need to put these tests in your research papers. You need to prove some hypothesis. Okay, because once you achieved some result, some result in analysis part, you need to put hypothesis. Okay, that statement is proved or not proved. Got it? Very important. Consider this thing as an important part. And the most preferred data distribution in statistics is normal distribution. This is the most preferred distribution in the statistics. That's what we call as a normal distribution, where mean, median, mode all are equal. It's like a bell shape. Mean, median, mode are all equal. This is called as normal distribution. Okay, sometimes also called as Gaussian, another name, Gaussian distribution. So therefore, while doing data analysis, we focus on data distribution, and especially those features which are continuous in nature. We expect that their distribution should be normal in nature. That is what our expectation is. And why? Because the ml algorithms do have this expectation. then only they will result in good. Unless and until you don't fix your data, you will not be able to get the good results, not at all. Okay, fine. So let me tell you the steps. Let me tell you the steps. You get a data, you get a data, or you collect the data. Okay, you get the data, you collect. Okay, you collect, and that will be in a raw format. Raw format, not well or proper organized. It's raw data, rough actually. It's a rough data. Okay, fine. Got it. So if it is a rough data, it's a raw data, then you require cleaning of the data. That is one of the major step in data science and machine learning, data cleaning, or we called it as pre-processing. Data cleaning or pre-processing. You need to clean the data. And all these steps which I am telling you need to write in your research paper methodology. There is section number 3. Okay, there is section number 3 in your research paper where you mention research methodology. In this you need to step number 1, I already told, data explanation, data set description. So that will come under data collection. Okay, data collection, data explanation will be there. In step number 2, you need to mention what steps you have applied to clean that data. That is called as pre-processing. Okay, so what actually we face difficulty in the data for pre-processing? The difficulties faced are number one, data is having duplicates, duplicate entry, duplicate row. That's what the data is having. Okay, we need to remove the duplicates. Second, null values, null entries, empty. Two possibilities: either you remove, either you fill. Either you remove, either you fill. If you are filling the null value, then then if it is continuous numerical and you want to fill it, you need to fill it with mean or median. If it is discrete or categorical, you need to fill with mode. Okay, this thing is done when you believe that the feature which is present in my data, it is important and I cannot remove it, then I need to fill it. Because removing something from the data is a loss, we consider it as a loss. We don't unnecessarily remove anything from the data, it is a loss. Either it is 1% or either 2%, 5%, it's a loss. So take a charge whether to delete or not to delete. You're deleting, then it's your responsibility. Filling, then okay, take a proper initiative by whom to fill. Okay, so duplicate you are fixing, null values you are fixing. Okay, now step number 3. In step number 3, if you are having text data, let's say you are dealing with the text data, you are available with the text data. So there are certain pre-processing techniques which you need to apply over the text data, like you need to convert a text into lowercase, you need to remove a punctuation mark, you need to remove digit, you need to remove the number, you need to remove hyperlink, you need to remove emoji, you need to remove extra patterns which are present in the data, brackets and etc, etc, any kind of pattern. You need to remove stock words like a, and, the, etc., etc. You need to remove all. This is how you need to clean your text. If you're dealing with a text project, you need to write, like, perform all these steps, and all these things will be mentioned in your research paper. You have to write these things into the research paper, that for text cleaning or text pre-processing, we have done all these things. Mandatory, whatever I am telling you, all things should be mentioned in the research paper. Okay, got it, fine. After that, you have to, okay, let's say you are dealing with images. Now you are dealing with images. In image, what you need to do for image cleaning, image pre-processing, you need to convert an image into a shape. All images should have a proper shape. Let's say 224 cross 224 resolution. You need to enhance the image. Okay, pixels quality, you need to enhance. Okay, you need to normalize pixels. Normalize means convert every pixel intensity between 0 to 1. Normalization. You need to perform augmentation. Augmentation. That means you need to rotate an image, you need to flip an image, you need to increase the brightness, you need to increase the contrast, you need to zoom the image. All these things you need to do over an image. That is a part of methodology. For image perspective, I am talking. Okay, so in pre-processing, you need to do all this cleaning stuff in methodology. Very, very important. Those who do pre-processing correct, they are the only people who are going to get success at the model. Else don't expect you are getting any success. No, no success. No success at the model part. Unless and until there is no pre-processing, then there is no correct, no, there's no more success at the model. If you don't know how to deal with the data, how you are going to get a success at the model part? No, because model is having some expectation. I already told you. We don't give data directly to the model and ask the model kindly give the prediction. No, 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 not at all. Without correct pre-processing, it's over. Okay, got it. You need to check the distribution of data. You need to check the distribution of data. Sometimes it happens that the data is skewed, and I told her that data should be, the most preferred one is normal. So you need to make plots, which comes under EDA, exploratory data analysis and data visualization. You need to do exploratory data analysis. You need to make the visuals and see how the data is showing the pattern. Okay. So you need to fix the data in pre-processing by seeing the visuals. In pre-processing, you need to fix the data. Okay, fine. So after doing all this stuff, making visuals, doing pre-processing, once you think that okay, now my data is clean, now my data is clean, then I can use a model. Now I can apply a model. So next step is modeling. Modeling. Now what model you are going to use? What model? Okay, my task is regression task, my task is classification task, or something else. So, as per the requirement of your task, you need to use your model. That is what you need to do. Okay. For regression, for machine learning, linear regression, decision tree regression, support vector regression, etc. etc. Neural network. You can use neural network also for regression. For classification, logistic regression, decision tree classifier, random forest classifier, or classification models. for clustering, etc., their own algorithm should be used here. So in model, are you building a model from your side? Your side. So obviously you are looking forward for the architecture. In architecture, you need to first read the architecture, understand the architecture which is developed by the previous person, previous author. Because once you understand their architecture, and in the conclusion part of the research paper, conclusion and future work, they have mentioned what are the limitations of their paper. They have mentioned the limitations of their paper. So you need to go through that. Okay, these are the limitations. Okay, and here is the architecture, these are the limitations, and we need to enhance the architecture. Okay, fine. We need to build where actually the problem is. Therefore, we can build our own architecture, our own algorithm, our own technique. We can build. Okay. So once your model has been done, model part is done, then you can have the model result analysis. Okay. We call it as evaluation. You need to evaluate model evaluation. You need to see whether your scores improved or not. Model evaluation, result analysis. You need to do. This is very important section. Remember, very very important section. Your paper will be accepted or your paper will be rejected depends on result analysis. You need to put all your efforts in writing result analysis. You need to include plots. You need to include tables. You need to write good section that what you achieved in result analysis. Very important this part. Okay. This will show your success. So as much as plots, as much as comparative table, as much as algorithm success scores which you achieved, you need to put it here. All right, fine. Because these keeps importance. Result, algorithm, methodology. These keeps importance. Okay. At the end, okay, you're looking forward in a research paper that you're also going to write the conclusion, you're going to write the future work. That is fine. Okay, but result section is very much important. Plot including tables are there. Okay, try to include as much as comparative plots because you are not working on a single algorithm. You are working on multiple algorithm. Every algorithm has given some results. So you need to use all those plots, all those images. Okay. What are the parameter you use for the evaluation? What is a parameter for evaluation? For example, in classification, we focus on accuracy, confusion metrics, classification report. Mention all. Okay, mention all. This much precision, this is the recall, this is the accuracy score we achieved, this is the confusion metrics. Okay, that plot should be there in your research paper. Okay, got it. So once you are being in a good for this result analysis evaluation, then you can okay have a good paper. Then conclude and write a future. What is next expectations from this work? Okay, got it. So like we are not as a research perspective. Once your model is trained, you have done the evaluation. Next come the deployment part. But we are not the industry people. Let's say we are the professors. So the deployment is something we are not like pushing this thing onto the hosting web services. Okay, so currently ignore this part. Okay, else this once the model is good, you can deploy the model over internet. This is what you can say. Some write in their objective or in their aim that we are going to build a end-to-end deployment ready service for this task. Okay, but if you are incorporating, then deployment is the next step. Okay, to create a website, to create a like a running web service, something, an application, or I would say an application which will show that how results are coming. It's a demo working. Okay, working live. That, but else in research, okay, whatever we got as results, we are publishing it. And if you have your deployment part, in case you have mentioned, so kindly put the screenshots that this is our website and this is how it's working. Got it? This much happens. Okay, fine. So linear algebra, statistics, data analysis, data understanding, very much important in the field of data science and machine learning. You are struggling with the paper writing. Actually, what the struggle part you are facing? What the struggle part you are you have you achieved the good results? Are you ready with your results? You good in coding, programming like Python? Because this is the language which I prefer for data science and ML. Python. You're good in Python. Good in coding. You know about the libraries which are used here. NumPy, Pandas, Matplotlib, TensorFlow, PyTorch. Are you aware of all these things? Where actually the struggle part is? Well, data. I told you start with the data. Now that you do the analysis. After analysis, then you need to use model part. We'll be doing some project here. Don't worry. I'll pick up the data from my side. I show the entire coding how I approach to that particular problem. Okay, and hopefully we are going to make a paper also. I'll talk about how to make a paper in latex format also. Overleaf. We are going to use overleaf. We are going to just understand that what are the important elements of overleaf, latex paper writing. What are the templates for it? We'll check. Okay, but overall, we need to make these things understandable. That what are the requirements? How we can fix the issues which we are facing in paper making. All right, got it. You have anything to say? You are having any doubt? Please let me know. Yes, any doubt? Please let me know. Yes, any doubt? Yes, ma'am.
Anybody, any doubts you can please ask.
So, ma'am, how's the first day session? Like, you can talk openly. You can say openly like.
Yeah, sir, it was basic. We could understand a lot.
Mhm.
Probably we expect more in the next few classes. Sir.
Mhm.
Yes, sir. Very informative workshop, sir, as far as this today was there.
Thank you,
But
ma'am.
it was only an overview of many things involved in paper writing, so we will probably have more doubts in the days that come.
Mhm. Okay, okay. So, as per the mathematical perspective, I talked about linear algebra. I talked about statistics. I am available with all the mathematical problems related to it. So, if you are expecting that, sir, kindly show us those maths. Okay, I will show that maths also. We do have probability also here, information theory also here, calculus is also available with us. Okay, so if you expect that those mathematical grounds in the next class, I will bring those concepts in front of you. We'll share some coding parts, some libraries in the Python like NumPy, Pandas, Matplotlib, which can be used for practice to see how the results are coming. Is that okay?
Yes, sir. We would like to see how it can be done, sir.
Mm-hmm. All right. All right. Thank you. Thank you. So I'm just getting the feedback here in the comments. All right.
Yes, sir. Yes,
And
sir.
in case, madam, still any topics more according to your concern or like the other faculty concerns, I'll incorporate here.
Yes, sir. I will just have a discussion with my other faculties
Yeah, yeah.
and come back to you if specifically they want one topic to be covered or.
Yes,
Uh,
madam. Definitely, madam. And before covering the project, what steps are required and how to start working on a particular project. Let's say if we take a project on tumor detection only, okay, so we
hmm.
can plan the entire paper for it, not an issue.
Okay, okay, sir.
All right, so
We'll have a discussion after this, sir, and just let you know what is our requirement.
sure, sure, madam, sure, please let me know. All right, fine. So we'll connect on next class as per our schedule, and then
Yes, sir.
we'll continue it. Okay, madam.
Yeah, yes, sir. Thank you for your informative session, sir.
Thank you, madam.
We would like to meet you back on 24th.
Yes, ma'am. 24.